And welcome all of you space weather enthusiasts. Today we're coming at you a little bit late because, well, it's the Sunday edition and we slept in. We are starting things out here by showing you some 24-hour videos from the GOES-R. The data feed is down from the SDO. And HelioViewer not returning data. So we've got some interesting features to talk about today for sure. Not the least of which are the coronal hole movements up around the northern polar region. 2 active regions rising in the southeast and a huge active region rising in the northeast. So here's a 24-hour video of that rising active region, expecting that to be a large sunspot as there is a huge plasma filament streamer behind the northeastern limb. The southeastern limb features again 2 new active regions that are about to rise. And a huge sunspot there ahead of the Earth scale as well. And that's the most likely place to see a large sunspot. I mean, to see a large solar flare is now down in the southeastern limb, I believe. Here's the southern hemisphere by itself. Great view of a coronal hole or 2 there. Briefly show the equatorial. Oh, here's the southwestern limb. Great view of that active region. And here's the equatorial zoom. And once again, the northern hemisphere does feature a migrating coronal hole. It's been hanging out at the heliographic North Pole, then moving down here and then back down here and then back down here again. So that is once again opening the floodgates to solar maximum. It's exciting stuff here at the Smash News Network, least busted name in news, and we're delighted to bring you the world's most detailed space weather and comprehensive solar imagery in the known universe. So not a lot of big changes happening here. Mostly stability in the data from yesterday plus today here. Of course, there is sunspot growth in this group right here. It's already got a name, I think. We'll get to that in a minute. Let's take a look at the colorized magnetogram. That is yesterday plus today. Once again, that's July 8th and July 9th to date. And we're going to take a brief look at what's going on terrestrially. And before we do that, please take a moment to visit our links. So just so you know, we make Just This Side of Nothing on our monetized YouTube channel. It's Just This Side of Nothing. So we have various paid promotions, one of which is our Redbubble shop. Today's featured product is the Galactic Federation Special Forces design. The symbolism features a spiral, which represents the Milky Way galaxy, which is the jurisdiction of the Galactic Federation Special Forces. The lightning bolt represents instantaneous galactic scale reach, signal strength, and the key represents signal integrity and security. The little bright spot in the upper right represents, whoops, that's classified. So if you would like to support the Galactic Federation Special Forces, pick up some merch and tell your friends and foes that we at SmashOmash.com said Universum Liberate. If that's too reckless for you, well, we're terribly sorry. We're not opening a portal to hell. We are just saying, free everybody. Yes. To quote Rush, if I could wave my magic wand, I'd set everybody free. If you're sick of what's going on in your locality, city, state, hemisphere, planet, solar system, interstellar region, consider the Galactic Federation Special Forces. Perhaps they'll solve your issues. And once again, Universum Liberate. Let's see what's erupting in terms of terrestrially. Yeah, terrestrially. These are the volcanoes that are currently erupting. Nishinoshima there, now back on the list as it explodes and produces a mile-high ash plume. It's a flight level 050, a 5,000-footer. Unknown volcanic ash plume there at Mount Mayon. It does appear to still be erupting. Popocatépetl in central Mexico exploding, flight level 190. It's a 19,000-foot ash plume. 24,000-foot ash plume over Colombia from Nevado del Ruiz. 20,000-foot ash plume over Ecuador from Sangay as it explodes. Also Revenador in that same nation, producing a 14,000-foot ash plume, flight level 140. Intermittent emissions of volcanic ash from Sabancaya, an indication that it's still erupting, no indication on the flight level. And Ubinas in Peru, not sure if that's erupting. Don't assume it's not. And again, please do not pole vault the caldera. Here's seismicity over the past 90 days, and getting into a bit of a 7 magnitude earthquake drought here. We've had quite a calm series of days here. Nothing over a 6 magnitude in several days. And here is the 24-hour list from USGS. We'll cite quakes of a 5 magnitude or above. There was a swarm of small quakes in the Caribbean. Perhaps a foreshock signal there. Most of the quakes there around the western Pacific. Largest quakes of the past 24 hours included a 5.6 at Taiwan. That was at 1947 Universal Time yesterday evening. And then a 5.1 aftershock there, right in that same region at 21:22 Universal Time. So only 2 5+ magnitude quakes there in the past 24-hour period of time, which brings us back to space. So here we've added 304 angstroms to the 195 GOES-R wavelength. That's ionized iron at 195 angstroms and ionized helium at 304 angstroms. And let's talk about some additional space weather stats. The 10.7 centimeter radio flux is currently at 161 solar flux units. There is the 1-year graph of the radio flux represented by the black line. The red line is a sunspot number, which was at 190 at the last time I saw a NOAA update. You can see it almost reached 200 once again as we continue to watch solar cycle 25 ramp up. So here is the solar cycle progression, by the way, if you're wondering. That's what's going on, and you can see it looks nothing like solar cycle 24. It's a much stronger cycle. It doesn't look like it's exhibiting a double peak or anything like that. It's just straight up ramping up. So you can expect nearly another year of increasing activity here. We're expecting like about 18 months of similar levels of solar activity as we have right now. Next, we'll look at the Space Weather Enthusiast dashboard. Since you are space weather enthusiasts, here's what NOAA has to say. No geomagnetic storms in the forecast. No major space weather events currently being forecasted by NOAA or by us or by NASA for that matter. Here's the past 4 hours of Earth's magnetic moment from space. So we're looking at about 12 Earth diameters here, and that is showing magnetohydrodynamic pressure. The units of that are nanopascals. Again, it is a calm situation with a rather weak solar wind at the moment. Next, Earth's magnetic moment from the ground. And this is depicting magnetic flux density, the units of which are nanotesla. It's also the last 4 hours. Again, it is a calm situation. And by the way, make sure you follow us on Twitter. If you don't, we did share one fantastic auroral video. I believe it was from Minnesota. So we did have brief periods of geomagnetic unrest in the past couple of days. And so we shared that. Planetary K-index currently at 1.33. That's a general average of global geomagnetism. And again, the solar wind is pretty weak. So let's take a look. And it has recently, in the past about 6-7 hours, has further weakened. Current situation is just under 400 kilometers per second for the solar wind speed. Solar wind density here very diffuse at only 1.2 approximately protons per cubic centimeter. Here are the data from the GOES 16 and GOES 18 magnetometers there. Pretty smooth readings, no real surprise there. No major changes to Earth's plasma environment. No impacts or anything like that. And let's take a look at a thing that does have an impact right there. That is an important one. It is the top view ecliptic plane field plot. And once again, let me attract your attention to this area right here. That is a coronal hole at the north heliographic polar region. And you'll see it leaving the north heliographic pole and then returning and then leaving and then returning and so on. When it leaves for good, that is perhaps the final signal that we'll see before we can really say that, okay, we can achieve solar maximum. But until that magnetism leaves the north heliographic pole, not so much, at least in my opinion. Of course, we're looking at very specific features here. These are the magnetic fields of the sun's atmosphere. So those are coronal holes, and the plasma in those coronal holes is polarized, which is what you're looking at in this imagery. And once again, it has left. All right, so if you look at the last image here, this depicts 4 days. There's the last image, and you can see that coronal hole has indeed moved down toward the equator. And we're going to show you some imagery of that. First, our line of sight field plot. The sun's B field depicted here in blue. That's sort of like the net field between that's sort of the net field of the interaction between the north and south polar fields. The extent to which they overlap is the B field. The B field being the field that goes through the magnet, and the sun being a polar magnet. North pole depicted here in green, south pole depicted in red. Photosphere magnetism depicted in grayscale. There is our line of sight coronal hole plot. Again, you'll see this coronal hole right here. It kind of makes its way down toward the equator as those north pole oriented coronal holes set. And let's bring up our 211 angstroms wavelength. So right up here, you'll see this motion. That coronal hole there, that is depicting, again, that's 4 days. You see that coronal hole leaving the north heliographic polar region and dropping down toward the mid-latitudes. That's a big deal because that is the solar polar field reversal process occurring before your very eyes. This is yesterday plus today, and it's very hard to see this happening because this plasma see this plasma right here? There's an active region right here, and this plasma here is very bumpy, and it is preventing a good visual depiction of that coronal hole motion. That is 211 angstroms, July 8th and July 9th to date. So July 8th and July 9th to date there in ionized iron, 211 angstroms. And let's move to sunspots. So here is our integrated space weather analysis center. Again, no new sunspots here as far as I can tell. That one by the equator's already got a name. It's 3367. And let's take a look at the SDO intensity gram here in grayscale. We'll zoom in to show all the sunspots in maximum detail. So there are all the groups. And once again, we're expecting 2 new regions to rise down here and 1 really large region to rise up here. There is a huge amount of plasma suspended behind the northeastern limb. Moving right along, we're going to go to energetic particles and solar flares next. As far as the solar energetic particle events, or SEPs, we ain't got none. The ghost proton flux, no spikes. As far as solar flares, we've only seen C-class intensifications for the past 24 hours. So nothing exciting going on there. There still is a possibility for large flares. We do still have magnetically complex sunspot groups on the earthly portion of the solar disk. And here comes some... Yeah, there's a 24-hour video featuring 131 plus 304 angstroms. Once again from the GOES-R. There's a zoom into the equator. And the most active region as far as flares has been this one down here. This is sort of the number 1, and this is sort of the number 2. Number 1, I order you to take a number 2. On YouTube channels that cite nonsense about space weather. Here we've subtracted the 304 angstroms. This depicts ionized helium and ionized iron. Here we've subtracted 304 angstroms to only show the ionized iron at 131 angstroms. And again, we do have another likely region to see a large solar flare. Right now it's the southeastern limb. As we say all the time on the channel, sunspots have a tendency to make a grand entrance and a grand exit, producing flares, especially the largest flares, right around the limb. In fact, many sunspots produce large solar flares without even being visible as sunspots from Earth. Anyway, there's a 24-hour video in 131 angstroms. And it's time to move on to things like coronal mass ejections. But before we do that, let's talk about what's going on overhead. We're at skyandtelescope.org now. I like their star charts. They're totally sweet. One of the reasons is because, well, you can make your own for your location, and then you can move this little green box around to see what the sky actually looks like. Not just this sky dome, but for example, if you look in the southern sky, there you can see the a constellation, something or other. Yeah, some constellation there hanging over the hanging over the horizon. There you can see Canis Major, and the brightest star in the sky there, right at the southeastern compass subpoint. And if you are viewing the dusk sky, you'll get a great view of Venus and Mars there. The third and fourth brightest object, depending on how close Mars is with respect to Jupiter, to planet Earth. Skyandtelescope.org is what we like to use. That is the current situation over our location at Lehigh Valley, Pennsylvania. Next, your solar system forecast. As we like to show this because we like to orient people before we talk about coronal mass ejections. In other words, coronal mass ejections that are moving this way are more interesting to most Earthlings than coronal mass ejections that are moving, say, this way, right? So we like to show this before we talk about those so people know where stuff is. Do we think that planets cause coronal mass ejections or solar flares or solar activity in general? Well, absolutely not. Do we realize that all the planets don't orbit the sun? The sun and the planets orbit the common center of gravity in the solar system, known as the barycenter. Does that control solar activity? Nope. Not according to all the scientific literature that I've reviewed. Here's your solar system forecast for the next week. As we approach a new moon, we will be at a tiny sliver, crescent waning moon, on the 16th of July, and here come CMEs. Yeah, CMEs. Are those earthly directed? Well, the answer is we don't think so. Those are pretty minor. That's 94 frames from yesterday, once again, July 8th. And here come an additional 45 frames from today, again coming at you kind of late today. It is, after all, the Sunday edition of the Daily Space Weather. Here comes some more coronagraphs. We're going to show the C3 as well. That adds a little bit of additional zoom out. The Soho-Lasco C2 and C3 together. So one CME there out of the northwest, one out of the southeast, another out. So the southwest and northwest, rather. Those are the spots to watch. And before we show our custom videos, let's take a look at stereo A. Feel free to pause the video on this frame if you're not familiar with the locations of Mars, the stereo orbiter, Bepi Colombo, Mercury, the Sun, Parker Solar Probe, Venus, stereo A and B. Stereo B shown here on the left. Once again, Soho Lasco C3 shown here on the right. Some huge streamers there around the left, the western limb, which would be on the right of your screen. And by the way, we call this side the west and this side the east because the sun rotates in this manner. And this is where activity rises and this is where activity sets. In other words, a sunspot rises in the east and it sets in the west. It is a heliographic notation based on the directions. Anyway, let's show our custom 24-hour videos. So here is 24 hours. You've got Soho Lasco C2 and C3 and the GOES are 195 angstroms wavelength. As far as those coronal mass ejections, I don't think there are any earthly directed components there. We're not seeing any major plasma motions there on the 195 angstroms wavelength and no halos on the coronagraphs. So we are expecting those coronal mass ejections to miss Earth. Here's a great zoom in for you. And by the way, the likelihood of additional coronal mass ejections is nearly 100%. Why? Because there are a massive number of filaments and huge streamers around the edge of the solar disk. So let's take a look at filaments next. Here is the ground-based observatory at El Teide, Spain. Alex Lifeson filament here still holding strong. These filaments could use names like this one here and this one over here. Yeah. If you want to name filaments after living people, join us on Twitter. Yeah, Twitter. By the way, we're also on Threads for all of you people who hate Elon Musk. Or who just love Facebook. Or Instagram. I don't know. We're on both. So check us out over there. You might see some information you don't see in other locations. I spend the most time, I guess, on Twitter. I mean, it's got the most interesting people and the most interesting posts to share as far as any social media. It's still crap, but it's less crap than the other social media, so that's the one that we are on the most. Not a fan of Elon, however. Elon does do some good things and some terrible things. So you gotta sort of take that all with a grain of salt, or when it comes to whatever Elon says about investment advice, take it with a truckload of salt. By the way, we are also on Instagram if you want to see all kinds of diet, lifestyle posts, fitness information, stuff like that, your daily motivation to go out and do things. You can also find our paid promotions below this video in the description section. So make sure you visit those links. Hemp Lucid is one of our paid affiliates. Check out those products. You can find a link below this video. Also on our homepage at smashomash.com, as we built a massive web ring to support these videos and to help out people like you from the pathetic, putrid, and disgusting censorship of online activity in general. So check out the CBD products. Maybe they can help you out with your daily activities. I took a stress gummy yesterday as I overdid it in terms of the training. So yeah, the stress gummies, they have cordyceps mushrooms in them. Maybe try the focus mushroom gummies. Those are fantastic too. In fact, I've yet to see a product that isn't fantastic from Hemp Lucid. So again, check out the links. You can also find a link to the Amazon shop. You can find things like battery backups, chrome hats, and more at amazon.com/shop/SmashTeam. Once again, links on the home page at smashomash.com. So join us over there. You can find additional content on all kinds of different social media sites. You can also find the link to the Spotify music page. Our record label is called Golden Cat Productions, founded back in the year about 2000. There's a link to the Amazon, Hemp, Lucid, a permanent invite link to the Discord chat. If you want to send an instant message, do it on Discord. You need an invite to get to the Discord channel, and you can find a permanent invite link to the Discord channel right there on the homepage at smashomash.com. And welcome to the Neo Renaissance. Congratulations on realizing the channel exists. And before we do bonus features, here come the past couple of hours from the GOES 18 SUVI. So there is a significant flare probability in 3 main locations. The first one being this one, secondly right here, and thirdly down here. In a short period, we'll have a 4th likely place for flares up here, but that's getting a little ahead of ourselves right now. 3 locations where we are likely to see large solar flares. And let's move to our bonus feature segment here, starting out with satellite charging hazards. There aren't any. It is smooth sailing for satellites. No high-energy electrons getting inside of circuitry, and no low-energy electrons building up on the outside of those spacecraft. Here is the GOES electron flux, which is measured by using radiography. From the geosynchronous near equatorial orbits of the GOES 16 and GOES 18, they measure that at the F layer of the ionosphere, which we will show you here momentarily. GOES electron flux here in a pretty smooth and moderate range. Here's the 1-year graph to put that in context. That is from solon.info. And NOAA is expecting flat levels here for the coming days. No argument there. I mean, I expect a little more variation than those 3 green boxes, which are the forecasts. But sure, okay. No argument from me there. Next, we're going to show the vibrational frequency of the F layer of the ionosphere. Feel free to pause the video on this frame if you're not familiar with things like temperature inversions. Yeah, the troposphere, it's warmer at the surface. The stratosphere is warmer at the top. The thermosphere is warmer at the top, etc. This also shows you the penetration of electromagnetic radiation. For example, if you're not in the mesosphere, you can't even measure X-rays. They don't make it to the stratosphere. They're adsorbed by the time they reach the stratosphere. And here's the vibrational frequency of the F ionosphere, which is, by the way, looking pretty normal, but we show it anyway on the channel every day to make sure that we archive the information, because you never know when a signal will emerge. A signal perhaps with predictive value. And if you want to read more about our mission to determine things with predictive value, join us over at the Smasho Forum. Yeah, Smasho Forum. Smashomash.com/forum. And down at the bottom of the page, you'll find our mission, smashomash.com/forum/mission. As we are interested in data that has predictive value. Remember, folks, correlation does not necessarily mean causation. It doesn't make it any less important in terms of predictive value. So here is the anomaly in the F ionosphere. That's anomaly in megahertz from the 30-day median. Again, pardon the lateness of this video. We slept in. It is Sunday after all. And we've taken about 3 or 4 days off in the past about 6 years. There's the latest image, 1345 universal time ionogram, 1345 universal time anomalygram. We also show the total electron content, which will show you the most likely places to see GPS errors. Did you know that your GPS must communicate through free electrons? Those free electrons can cause signal refraction. I mean, you've got the inner portion of the outer Van Allen belt, you've got the outer plasmasphere, the inner Van Allen belt, the inner plasmasphere, and the ionosphere. And this total electron content depicts the free electrons all the way up to about 12,500 miles of altitude, which is approximately where your GPS satellite is located. These are the most likely places to see GPS errors. It's It's the coupled thermosphere, ionosphere, plasmasphere electrodynamics model. Not to be confused with the electron flux, which is only measured at one slice of the atmosphere. This is the full count, all the way up to the inner portion of the outer Van Allen belt. Here's the anomaly from the 10-day average for North America. We are seeing some minor signals here over Central America and southern Mexico of high electron contents. So right in this time frame right here, some significant signals there around like Guatemala. And there could be an Earth-based radiologic signal there, which could be a pre-earthquake indicator. So we show these regularly on the channel. If we're going to start forecasting earthquakes, we're going to start doing it for North America first. At the moment, we're not claiming to forecast earthquakes, but there could be data here that does precede those. It's time to close out the space weather section of the video. And we're going to start out with the latest high-res solar intensity gram. So there you go. There's a refresh. Here's the solar magnetogram. Do we have any new sunspots yet around the eastern limb? Well, the answer is no. Here's your full disk rockback. Again, there is a possibility of large solar flares. I mean, this one right here, that is beta gamma delta class. This one down here. That one is that one's only beta gamma class. This group down here is actually somewhat promising. Anyway, there still is the possibility for large solar flares, and let's move to meteorology. We're starting out looking at pressure. Are you under pressure? Yeah, we're under pressure. We're about to go out of business as an organization, and we're trying to, prevent things like becoming homeless. It turns out in the year 2023, citing facts creates an issue. Apparently, it is easier to get an orca to sit down for coffee with a falcon than it is to get anybody to pay me a single red cent for anything. It's fun stuff. Anyway, we hope you're not under pressure. Here is the lowest pressure in the world. It's actually pretty calm seas around the planet at the moment, but there's the lowest pressure. Of course, if that was in a summer ocean, that would be a tropical system or a hurricane possibly. It's 952 hectopascals there in the Southern Ocean. That is the stormiest place in the world right now. As far as the rest of the oceans, it's pretty chill right now. So for all of you mariners out there, pretty calm seas. We doubt you are sailing around Antarctica. So that's the world's lowest pressure. And let's switch to our wind maps here. And by the way, thanks for tuning into the Smash News Network. Least busted name in news. These are the surface winds of the eastern world. Here are the jet streams of the eastern world. Moving to the west, here are the jet streams of the central planet. The Holy Lands, Africa, Europe, the Middle East, Central Asia. Jet stream blowing backward there over the northern portion of the Indian Ocean and northern Africa. Here are the surface winds. There is a low there in between Ireland and Newfoundland. So it's a bad day for Vikings to be crossing the Atlantic. Perhaps. Little higher seas likely up there. These are the surface winds of the west. And like sands through the hourglass of time, these are the jet streams of your lives. Check it out, folks. It's an atmospheric river Styx. It's not really an atmospheric river Styx. I'm just being facetious. All right, so let's talk about soil moisture. There's some significantly anomalously moist areas there in places like Kansas and Oklahoma City, and some anomalously dry areas in places like Wisconsin. Here's the drought intensity map showing similar. And by the way, by tomorrow, that will subside a bit. And throughout the week, expecting it to subside further there. That's a good sign, folks. That is a good thing for food prices, which hopefully are not continuing to just simply, accelerate up and up and up until the point where it costs you $1,000 for a loaf of bread or something like that. Is it a result of the food prices? Is it a result of the food actually going up in price? Or is it a result of the dollars actually going down in value? So anyway, dollars to donuts, this is what's going on over the Americas. That is clouds and fog. A lot of low clouds there over the southern Pacific Ocean. Also off the northern Pacific Ocean as well there, showing a lot of low clouds. That's shortwave infrared radiation, 3.9 micrometers, the NASA GOES Interactive Weather Satellite Suite. Next, our weather.gov map, and check it out, folks. Quite a bit of flooding here in the Northeast. The East in general, also Oklahoma and Kansas, showing some flooding and some heat advisories there. We've scrolled down to show you the key. If your location's lit, click your location at weather.gov. Those are too many counties to cover in detail. Looks like some good surf at Hawaii maybe as well. So next is there's our jet stream forecast. The jet stream will be remaining coherent here for the next 3 days, it looks like, according to the GFS model. That's a GFS 72-hour, 250 millibar wind speed map. It depicts the jet stream. Here is our pressure and precipitation map. And the heaviest storms here are going to be coming in about 3 days, especially to Nebraska. A big block of red there, and it looks like they'll be training. In other words, multiple storms hitting the same location. That's a GFS 72-hour pressure and precipitation map. We'll also show the GFS 72-hour total accumulated precipitation map. Large swaths of Vermont there, expecting like 6 inches of rain. So 6 inches is a lot. New York is also going to get a lot. Also, isolated portions of Pennsylvania. In other words, we're going to get like 3 or 4 inches of rain right here in Lehigh Valley. That is your GFS 72-hour total accumulated precipitation in inches. Next, we'll show lightning. That's what's been striking the past about 10 hours. Heavy lightning there, moving toward the Gulf states, as we forecasted yesterday. Here's a current lightning map. We'll briefly show that from lightningmaps.org. Next time you hear thunder, check it out. You can actually use it to forecast thunder. Hey, Texarkana, you are in the crosshairs. There is lightning all around you, and it's coming in your direction. By the way, if you haven't read 40 Lines of Evidence for Condensed Matter, The Sun on Trial, Liquid Metallic Hydrogen as a Solar Building Block, we highly recommend it. It's already 10 years old this year. It's passed peer review in the year 2013. It's got hundreds of scientific citations. And the reason I bring it up here is because, well, super ionized materials are not just the future of cosmology. Super ionized materials are the future of technology, in my opinion. So, I mean, this is not really new stuff, folks. Here's an article on Wikipedia about super ionic water. Did you know that when you get water under about 4 million atmospheres of pressure, water actually turns into a crystalline lattice structure? Yeah, it's one of the 19 known crystalline phases of ice. Yeah, it's pretty funky. And when you apply an electric field to that, the positive hydrogen ions migrate toward the anode, just so you know. I don't know if you care. Super ionic water, yeah, it turns into a cubic lattice structure. Water does at about 4 million atmospheres. And then you've got liquid metallic hydrogen sloshing around inside of it. It becomes about as conductive as metal And keep in mind, liquid metallic hydrogen is metal. It just needs about 1 million atmospheres of pressure to become a metal. By the way, these videos are brought to you in part by the contributions of the Smash Team members. Smashomash.com/Smash Team is our own subscription services site. We are still on Patreon. If it's more convenient for you to donate to us that way, feel free, but we created our own because it's simply better. Smashomash.com/Smash Team. We sent out a gold Smash Team level member only post just yesterday, as we provide additional content, especially for gold and silver Smash Team members. We even send out email notifications, even to bronze level members, for outputs of videos just like this one. Yeah. Why? Because people complain about no notifications on YouTube, so we've solved that problem. With our own website, you just have to sign up for email notifications. Seems very simple. But you know what they say? You can lead a horse to water, but you can't make him drink. Smashomash.com/Smash Team. And let's close this thing out with a close-up. I told you Texarkana is in the crosshairs. And the strongest storms here are on their way to Arkansas and Louisiana. Anyway, here's your full 50-state zoom out for a brief moment there. Some activity in the Bering Sea in terms of precipitation. Here's a lower 48 view. Here is clouds and fog. And here is water vapor. So once again, we've got a blocking feature here. You've got this dry mass of air ahead of this moisture, and that is causing a compression. We've got an impulse this way. We've also got cold air intruding down from Canada. And so this relative low is kind of stuck in there and constrained as that moisture gets mopped out of the atmosphere. It's a mop-up. Here's your recap, U.S. Doppler radar. Clouds and fog over ALSA, the allegedly United States of America. Former nation, now banana republic. Here are the water vapor data from the NASA GOES Interactive Weather Satellite Suite. And thanks for tuning into the Smash News Network, least busted name of news. After exposing all of this spooky, scary stuff about space and Earth, it's time for me to head back to the bunker. Let us know in the comments if your bunker is superior to Bezos' bunker. In the meantime, may that solar wind be at your back. I am out of here, bunker. Hear me call your name, because I'm going back to the bunker again. Whoa!